There are a few warnings that go along with calculations of arc length. One of the warnings is that arc length depends on speed, and because speed depends on derivative, it's very easy for two paths to look very, very similar, but for one to be much longer than another. So for example, we could have a path that moves smoothly through space and has a relatively short distance it travels, where another path kind of wildly winds around and around and around and around inside space. And it stays very close to the original path, but it takes a much longer distance to get from point A to point B. So we can't just calculate length by writing down paths that look close to the original. So sometimes this is called the coastline paradox, that it's difficult to calculate the length of a coastline by kind of taking a bunch of approximations because they may not converge in a very good way to the original. Or this is, the internet is full of proofs that pi is 4 and stuff like that, which make use of something like this. It looks like the length of a curve is approaching the length of a circle because the curve approaches the circle, but that's not the case. It's being very inefficient about the distance it travels. The second warning is a little bit more practical. When we calculate arc length, we have to parameterize an object and make sure that we only kind of cover the whole object once. So for example, when we're parameterizing a circle like this, one parameterization is given by a trig parameterization. C of t is cos t comma sine t, but we have to be careful when we're calculating the length of that we get an interval that covers the entire circle exactly once. So we could go between minus pi and 2 pi, minus pi and pi, or we could be going between 0 and 2 pi or something like that. Whatever covers it exactly one time. We have to make sure that we don't accidentally kind of cover half of it, and we have to make sure that we don't accidentally cover it twice or anything like that. We have to make sure that our parameterized curve goes around the whole thing exactly once. It doesn't backtrack and be inefficient in that way if we want to get a correct calculation of arc length. The third warning is it isn't conceptual at all. Arc length involves speed, speed involves length, length involves taking the square root of a sum of squares of a couple things. And so arc length integrals are very, very sensitive. They're very, very prone to problems when actually doing the integral because you're integrating a square root of something, and those integrals tend to be relatively ugly. So you have to be careful when you're doing arc length integrals. If they're on an exam, for example, they're usually cooked up so that they're doable, and making a small mistake can very, very easily nudge it into the territory of integrals that can't be calculated. So be careful when you're doing the calculation.